the Phobos monolith of Mars moon. And yes, we're supposed to be landing on Phobos. That's going to be happening before we land on Mars, from what the schedules are saying. Now, Buzz Aldrin told us about this, the Phobos monolith. Remember what he was saying when he said, well, yeah, there are aliens. Because look, one of the examples is the monolith on Phobos. It's a huge monolith. And he says, gee, look at it. Who put it up there? Now, the Phobos monolith, obviously, is not a natural structure. It's a large rock on the surface of Mars moon. It's Phobos here. This is according to Wikipedia. The boulder, about 279 feet across and 300 feet tall. Although to me it looks a little bit taller because it casts a very long shadow. Thin, long shadow from the pictures of it. The monolith is they say here, is a geological feature. Okay? Consisting of a single massive piece of rock. You have to remember, this is on the moon, it's not on Mars. Even though we've had very strange features and artifacts on Mars. For example, the face and even triangular pyramids. And that's on Mars itself, but this is on the moon, the biggest of the two moons of Mars. They say this is a geological feature, and that we also have monoliths on Earth. Now, this monolith on Mars is near the very huge crater that we know that it has. Is this something struck it? That's the Stickney crater. It's described as a boulder-sized, building-sized boulder, which casts a prominent shadow, this monolith. It was discovered by Efrem Palermo, who did extensive surveys of Martian probe imagery, and later confirmed by Lan Fleming, image subcontractor at NASA Johnson Space Center. Fleming considered the possibility that Phobos monolith may be artificial and not a geological feature of rock. Well, yeah, that's what it looks like when you cast a very tall, long shadow. The general vicinity of the monolith is proposed landing site. It is going to be the landing site by Optech and the Mars Institute. Okay, that's where they want to land for an unmanned mission to Phobos known as PRIME, Phobos Reconnaissance and International Mars Exploration. The PRIME mission would be composed of an orbiter and a lander, and each would carry 4 instruments designed to study various aspects of Phobos geology. At present, PRIME has not been funded, does not have a projected launch date. Former astronaut Buzz Aldrin has spoken about Phobos monolith in his support for a mission to Phobos. The object appears in Mars Global Surveyor images, and this is one of the images here that we have of it, dated 1998. The object is unrelated to another monolith located on the surface of Mars, which NASA noted as an example of a common surface feature in that region. Okay. Anyway, this monolith is found, if you're looking at Stickney crater being at the 4 or 5 o'clock position, horizontally towards the west is the monolith. I believe it's artificial because it's so uniform in its length. It's like a column. Okay, so Phobos is a very strange moon. It's got striations on it. It's got put marks on it. Now, they say that the striations are caused by asteroid strikes, but how is it that the asteroid strikes run horizontal to each other, perfectly horizontal to each other, and in the same depth, and they run across the whole surface of the moon uniformly? All right. I'd like to go into the, again, I'm reading from Wikipedia, but I'd like to go into the there's a hollow Phobos hypothesis. Someone called Shklovsky in the late 1950s, 1960s, an unusual orbital characteristic of Phobos led to speculations that it might be hollow. Around 1958, Russian astrophysicist Yosif Samuilovich Shklovsky studied the secular acceleration of Phobos' orbital motion, suggested a thin sheet metal surface for Phobos. Thin sheet metal structure. A suggestion which led to the speculation that Phobos was of artificial origin. Shklovsky based his analysis on estimates of upper Martian atmosphere density and deducted that for the weak braking effect to be able to account for the secular acceleration, Phobos had to be very light. One calculation yielded a hollow iron sphere only 9.9 miles across, but less than 6 centimeters thick. Less than 6 centimeters thick? That's very little. In a February 1960 letter to the journal Astronautics, Fred Singer, then science advisor to U.S. President Dwight D. Eisenhower, said of Shklovsky's theory, quote, "If the satellite is indeed spiraling inwards, as deducted from astronomical observation, then there is little alternative to the hypothesis that it is hollow, and therefore Martian-made. The big if lies in the astronomical observations. They may well be in error, since they are based on several independent sets of measurements taken decades apart by different observers with different instruments. Systematic errors may have been influencing them." End quote. Subsequently, the systematic data errors that Singer predicted were found to exist, and the claim was called into doubt, and accurate measurements of the orbit available by 1969 showed that the discrepancy did not exist. Singer's critique was justified when earlier studies were discovered to have used an overestimated value of 5 centimeters per year for the rate of altitude loss, which later was revised to only 1.8 centimeters a year, still going into Mars. The secular acceleration now attributed to tidal effects, which had not been considered in the earlier studies. Now, the density of Phobos has now been directly measured by spacecraft to be 1.889 grams per cubic centimeter. The observations are consistent with Phobos being a rubble pile. In addition, images obtained by Viking probes in the 1970s clearly show a natural object, not an artificial one. And we're talking about Phobos as the moon, not the monolith here. Nevertheless, mapping by the Mars Express probe and subsequent volume calculations do suggest the presence of voids and indicate that it is not a solid chunk of rock, but a porous body. The porosity of Phobos was calculated to be 30%, or a quarter to a third being totally empty. Very interesting. The missions considered: 1997-98, the Aladdin mission, selected as a finalist in NASA Discovery program to visit both Phobos and Deimos and launch projectiles at the sites. The probe would collect the ejecta as it performed a slow flyby. They would return to Earth to study 3 years later. In 2007, European Space Agency, EAS, the EADS Astrium reported to have been developing a mission to Phobos as a technology demonstrator, and Astrium was involved in developing a European Space Agency plan for a sample return mission to Mars as part of the Aurora program. Sending a mission to Phobos with its low gravity descent would seem a good opportunity for testing proving technologies required for eventual samples returning from Mars missions. Proposed missions: 2007, the Canadian Space Agency Optech mission; 2008, NASA Glenn Research Center studying Phobos and Deimos sample return mission. Another concept of a sample return mission from Phobos and Deimos, OSIRIS-REx-2, which would use heritage technology from the first OSIRIS-REx mission. As of January 2013, the Phobos Surveyor mission, under development by collaboration with of Stanford University, NASA Jet Propulsion, Massachusetts Institute of Technology. The mission is currently in the testing phases, and the team at Stanford plans to launch mission between 2023 and 2033, so it's not off yet. So you can see a lot of these missions have not yet landed on Phobos. In March 2014, a Discovery-class mission was proposed to place an orbiter in Mars orbit by 2021 to study Phobos and Deimos, Mars moons, through a series of close flybys. The mission is called Phobos and Deimos and Mars Environment, PADME, P-A-D-M-E. Two other Phobos missions that were proposed for the Discovery 13 selection included a mission called Merlin, which would fly by Deimos but actually orbit and land on Phobos. And another one is Pandora, which would orbit both Deimos and Phobos. The Japanese Aerospace Exploration Agency, JAXA, unveiled June 9, 2015, the Martian Moons Exploration, MMX, sample return mission targeting Phobos. MMX will land and collect samples from Phobos multiple times, along with conducting Deimos flybys, observing and monitoring Mars climate. And by using a core sampling mechanism, the spacecraft aims to retrieve a minimum of 10 grams of samples. NASA, ESA, and CNES, also participating in the project, will provide scientific instruments, and the U.S. will contribute the neutron and gamma ray spectrometer, NGRS, and France the near IR spectrometer. Although the mission has been selected for implementation, is now being beyond proposal stage. Formal project approved by JAXA postponed following the Hitomi mishap. Development and key testing of these key components include sampling and is currently ongoing. As of 2017, MMX scheduled to launch 2024 and will return to Earth 5 years later. This is part of the human mission to Mars. Phobos has been proposed as an early target for human mission to Mars. The teleoperation of robotic scouts on Mars by humans on Phobos could be conducted without significant time delay. Planetary protection concerns in early Mars exploration might be addressed, such as an approach. The moon Phobos has also been proposed as an early target for a manned mission to Mars because a landing on Phobos would be considerably less difficult and expensive than landing on the surface of Mars itself. A lander bound for Mars would need to be capable of atmospheric entry and subsequent return to orbit without any support facilities, a capacity that has never been attempted in a manned spacecraft, or would require the creation of support facilities in situ, a colony or a bust mission. A lander intended for Phobos could be based on equipment designed for lunar and asteroid landings. Additionally, the delta V to land on Phobos and return is only 80% of that for a trip to and from the surface of the moon, partly due to Phobos' very weak gravity. As we said, it's 30% empty. The human exploration of Phobos could serve as a catalyst for the human exploration of Mars and be scientifically valuable in its own right, and most recently was proposed that the sands of Phobos could serve as a valuable material for aerobraking in the colonization of Mars. What is aerobraking? It's a space flight maneuver that reduces the high point of an elliptic orbit apoapsis by flying the vehicle through the atmosphere at the low point of the orbit. The resulting drag slows the spacecraft, and aerobraking is used when a spacecraft requires a low orbit. All right, so they'll use that. Because of the small delta V budget of Phobos, a small amount of chemical fuel brought from Earth could be used to lift a very large amount of sand from the surface of Phobos from a permanent outpost to a transfer orbit. This sand could be released in front of the spacecraft during the descent maneuver, and then resulting in a densification of the atmosphere just in front of the spacecraft. So there we go. It's basically hollow, very thin. It could be artificial. I'm talking about the whole moon being artificial. And from the looks of it, to me, I mean, that looks like a column and the shadow of a very straight column. It doesn't look as if it's a square, bulky rock. All right, tell me what you think. And we're off to Phobos before Mars, as you can see. I'll leave links below for you for this. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.